derivative of the first times the second plus the first times the derivative of the second. So the derivative of the second, 5 comes down, inside stays the same. Subtract 1 from the power. Oh, thank you. Times derivative of the inside, which would be? Okay. Final step, just clean up as much as you can. So at the very least, I want you to multiply the 2 and the 3 to make it a 6 times your 2x plus 4 squared, x squared minus 5x plus 6 to the 5th. On this one, at the very least, pull your 5 out in front. You guys understand that we could really multiply all this and get just a nice polynomial at the end if we wanted to, right? We aren't taking the time to do that, but I want you to realize you could if you needed to. All right, is that one okay? Yes, ma'am.
When you pull up, like when you pull the front to the 5 to the front, does it matter like what order you have of them?
No. Let's do. Say I gave you the square root of x plus 5 over 2x squared minus 4 to the 6th. If you see a square root, what kind of power is that? A 1/2. So you could do it as 1/2. Now you have different options on this. Quotient rule is what a lot of people think of first. I know I've seen some of you that like to bring up the bottom and make it a -6 power and then do the product rule and do it exactly like the last one. So both options are fine. Do you want to do quotient or product?
I have a question. If you bring the bottom up, does that just make it times the...
Yeah.
Okay.
Hey. Alright, so do we care? Product or quotient? Alright, let's just do quotient. So low D high. So this is like a 1/2 power. So the 1/2 comes down, inside stays the same. If you subtract 1, 1/2 minus 1 is -1/2. Derivative of the inside is just 1 minus high D low. So the 6 comes down, inside stays the same. I don't have enough room. Times, or subtract 1, times the derivative of the inside, which would be 4x over low squared. If it's to the 6th and I square it, that would be 12. Okay. Simplify. Multiply my 6 and my 4x. Okay. To simplify from here, we do have this 2x squared minus 4 in all of them. I also have a 1/2 on the top. I don't really want a fraction within a fraction, so I'm going to take top and bottom times it 2 to cancel that, and then I'll drop out one of my others. So the 2 and the 1/2 will drop. I can cancel out 5 of those. that okay? Yes.
How come you multiply that to?
Just to get rid of this 1/2, because I don't like a fraction within my fraction.
Do you have to do that?
I would probably take off a 1/2 point if you didn't.
If we did it the correct rule way, and then it still has a half. And
That's
everything.
okay.
Okay.
Alright, trying to think. If I asked you to write the equation of a tangent line, we've done that a ton. We can still do it even though we have this new rule. If I ask for equation of a tangent line, you have to do your derivative to get the slope. Like if I wanted the equation of the tangent line at this when x is 1. You would plug a 1 into this to get your slope and then use your point slope to write the equation. So you guys could do that?
Yeah.
Yeah, good. If I gave you, there was one on your homework that you had to do like a second derivative of a trig function. Did you guys do okay on that one? What was the problem? I don't remember.
It was y cosine x.
Cosine of x squared? So, first derivative. Derivative of cosine is negative sine. Inside stays the same. Times derivative of the inside, derivative of x squared is 2x. So you get negative 2x times the sine of x squared. When I do the second derivative, now I have 2 x's. I have, I have the x in this term and this term, so we have to do the product rule. So product rule is derivative of the first times the second plus the first times the derivative of the second. So derivative of sine is cosine, angle stays the same. Derivative of the angle is a 2x. And so you could get that for your final answer. Bless you.
Sweet.
If I asked you to do the derivative of say I gave you something with an e. Let's practice
Oh
that.
yeah, can we go over number 15 on that
Okay.
one?
Can I change it a little bit? I want to throw something else in it. So 15 was like x e to the negative kx. What if I made your exponent like negative 1 over x squared? I'm just going to change the exponent a little bit. On that one, k was just a constant. But what's another way you could write that exponent that might help? X to the negative 2. So if you had that fraction within an exponent, you might just rewrite it. So here again, we have x in 2 places being multiplied together. So we're going to do the product rule. So derivative of the first, derivative of x is 1, times the second, plus the first, derivative of the second. Derivative of e to the x, or e to a power, is still e to that power. But since the power wasn't just a plain x, you have to do a chain rule, so derivative of the exponent. So the negative 2 comes down, so give me a positive 2, x to the negative 3. When I multiply those together, you would add your exponents, so you would get 2x to the negative 2. And we'll get that for our final answer.
The 2 is a negative.
Because negative 1 times negative 2. Negative positive.
Would it not be negative 3?
It was, but I multiplied it with this term.
Okay.
So I added those. Okay. I'd like to do maybe one last problem. We're gonna run short on time, guys. 33. So, derivative of something to a power is still something to the power. If your base isn't e, I told you have to multiply by the natural log of the base. That's the derivative of the outside part. Now you have to do the derivative of the inside, so the derivative of that. So derivative of sine is cosine, angle stays the same. But we're going to have to do the derivative of the inside again. What's the derivative of pi x? And not a whole lot you could do to simplify that. You could drop your parentheses, but really you can't actually multiply anything together. I wanted to look at, why don't you guys, do you have your books handy? No? Alright, I'll write it down real quick. Let's say, and I'm going to tell you these things. I want you to find f prime of 5. So what we have to do here is take the derivative of this expression up here. I didn't actually tell you what it was equal to, I just wrote it in function notation. But we can work through this. When you do this derivative, you start derivative of the outside. So the derivative of f would be f prime. Inside stays the same. Times the derivative of the inside. Derivative of g of x would be g prime of x. That's my derivative. That's the definition of the chain rule. Is everybody okay there? So then if we plug in, my x was 5. Okay, what is g of 5? Okay, f prime of -2 is 4. G prime of 5 is, we get 24 for our final answer. Okay, questions there?